For the screencast of chapter 17, I have chosen a problem from book which says that there is a thin spherical shell which is uniformly negatively charged, is negative Q1, and there are two large discs made of glass which are charged positive Q2 on this side and negative Q2 on this side, and D is the distance from 1 to 3 and R1 is the distance from 1 to 2, and it says that D is much smaller than R2. So for number A, it asks to find the potential difference between V2 minus V1. This is a rough diagram of electric field that I have shown here. The electric field due to the disc will be in the upward direction, and also the electric field due to the sphere will be in the upward direction because of this negative and positive charges over here. And also inside the spherical shell, the electric field will be zero, mainly due to the static equilibrium, and so the net electric field is entirely due to the discs. So to find the potential difference between location 1 and 2, what we do is V1 minus V2 is negative A electric field due to the disc and delta Y, where this negative is due to the region that is in the path in the direction of electric field, and the E disc is the magnitude of electric field due to the disc, and delta Y is the location between 1 and 2. So now to get the electric field due to the disc, it can be got by E disc is equals to Q2 over A by E naught, where Q2 is the charge on the last thin glass disc that I showed you earlier, and A is the area of the disc, and area can be given by pi R2 square, and so the E disc will be pi Q2 over pi R square E naught. And as you know that location 1 to location 2 is R1, it's the radius of the cell, so delta Y equals R1. So just substituting the value that we got of E disc and delta Y, it comes out to be this much. So just bring this side and V2 on this side and negative V1 on this side, we get a value of Q2 R1 upon pi E naught R2 square, which is the potential difference. For the problem number B, it asks find the potential difference V3 minus V2. The potential difference due to a sphere can be given by negative, taking the limit d to the R1 is sphere is dy, and the electric field due to the sphere can be given by sphere equal k negative Q1 upon Y square. So just putting this sphere on this equation, we get V as V to V this much, just doing simple calculation. So the potential difference due to the disc is negative E disc D minus R1, where is D minus R1 is the difference, and as we got earlier, E disc can be substituted by Q2 pi R2 square E naught. So like before, the potential difference can be got by just adding the value that we had, that is V2 minus V3 equals potential difference due to a sphere and potential difference due to the disc. Just substituting the value, we get a value of this much. And for problem we will see, it says that if plastic shell is replaced by the metal sphere, what will be the magnitude of the potential difference? The potential difference between 1 and 2 will be 0, mainly because due to the polarization, the upper and lower part of metal sphere will have more negative charge, hence in it will be 0. Thus the potential difference will also be 0, hence the magnitude will be less than before.